How many players are there here? Obviously. 3. What are they?
First.
Yeah, first angle, second angle, third angle. Now this one's a little bit different than any one we've done before. I don't know if you guys see it. The second is twice as large as the first. The third is 60 degrees less than the second. So what is it that starts me off? Which one has to be just x?
First one.
The first one. Because then I can build the second, and then the second one helps me build the third. We haven't seen a problem like that yet. So if I call the first one x, what's the second one? 2x, I love it. And then the third is 60 less than the second. 2x minus 60. All right, let me stop for a second. You guys all notice that's a little bit different. We've never had one that was dependent on some middle step like that. But that's not that much different than the stuff we've done. And like we just said, what's supposed to happen for these? What equation can I make? What has to happen with all the angles in a triangle? They have to add up to be 180. That's the equation. The equation represents the relationship amongst all the players. Holy crap. I didn't want to do that. Oh, no, stop it, Jeff. Everybody's getting seasick. I'm sorry. This thing is so dark. Okay. Do you guys, is that okay? What's up? You guys all right? So then I get 2, 4, 5x minus 6. D. I just gave up on the poor number halfway through. Plus, right? And then we should be able to finish this out, right? 5x is 240. Divide by 5. X is 48. Just to remind you guys, when I divide by 5, if I double this, 480, and then move the decimal back 1, 48, bam. Or some of you guys can go, I got this thing, it's called a calculator. So what's that? What's that? So what do I write here exactly? There it is. Sweet. Got to put them units on there. Yeah, good. And then the second one, 96 degrees.
36.
And then this one, 96 minus 60, 36 degrees. Kick ass. And how do you check it? Add them all up, make sure they make 180. I like it. All right. I felt a little McConaughey in there.
Wait, I was still reading.
I'm sorry.
Kelly C.
Okay. So the thing students forget is when I'm talking about angles in a triangle, I don't have to tell you they make 180. You have to know they do. So that's the missing piece to make the equation. So you got to remember that's true. I think last time we did the last one and the first two last time. So look at number 4 on the other side. I love this problem. Sorry. I know. I'm very often the only one with a certain opinion.
They charge you
In
for
the room.
minutes.
Huh?
They charge you per minute.
Per minute, yeah.
Is that a real thing?
That's what they used to do. I don't know what they do anymore.
They still do that.
Yeah.
Really, like a minute of
Yeah,
their
you can call the
time.
psychic and ask.
Dude, I'm gonna start doing that. What? No, I'm gonna start charging. Like 20 minutes.
I want to see the commercial you make.
20 minutes, you've already made
Please,
one.
make a commercial about your psychic business. I want to see that. Call me up. It's better than just guessing. Maybe.
I'll tell you something.
I actually, when I teach statistics classes, there's a certain point in the semester they learn enough, we actually test each other to see if we have ESP. Yeah, so we see if we outdo just random guessing by enough to be evidence that they have ESP. In the last couple semesters, somebody passed the test, and then I tested them, and then they passed the test again. And I was like, I got to start wearing my tinfoil hat so you can't read all the answers. I don't know, it kind of freaked me out a little bit. All right, so you guys hopefully have read through this, even with my distractions. What is it that I don't know? Yeah, the minutes. In fact, this is a little bit of a, well, let me just say this. Yeah, sure. We'll say X is minutes, right? Now this equation is going to be interesting. $4 for the first minute, and then $1.25 for each additional minute. Huh? Not really. So I'm going to make, oh yeah, I see what you mean. I thought you made the problems horrible.
No.
Yeah, I'm not going to pay that much money for, all right. So if I actually make one little change here, additional minutes. X is the additional minutes. So if you talked to the psychic for 5 additional minutes, how much money you got to pay base? No, come on. Base, $4. Plus $1.25 times the 5, right? You guys with me? And again, you can always do this. Just give yourself a number, figure out what the unknown is, and then make it known for yourself. Make it 10 minutes. Then it would be $4 plus $1.25 times 10. So what do I do? It's X minutes. So what would the equation? That's going to be a neat part. Oh, there you are. Let me make sure for the people at home, we're all safe. It was not. It was a highly local event. And I got this thing with Gorilla Glass, thank the gods. All right. Let's see. Still going. Sweet. All right. Let's see. Where am I left at? I've left myself no room back here. So what I got to pay $4 no matter what for the first minute. I got to pay $4 plus $1.25 for each. So that's times I don't know how many minutes. And what do I want that to equal? Yeah, I'm going to spend all the money I got to get as much as I can out of this psychic. I like it. And it might help if the psychic took me the semester before. They might actually have some insight. And now you got an equation to solve. There's one little thing you got to be careful about. Right? The equation is not horrible to solve. If I were you, I wouldn't even clear the decimals. Right? If you got to subtract 4, what do you get? What do you get? 1250. And then divide by
10.
Yeah, you get 10, right? Does that mean the answer is 10? What's the answer? 11 minutes. 11. Right? Because I got to pay for that. I got to pay for that first minute. So 11 minutes total. Now, if they give you a problem like that on the test, I'm not going to kill you if you forget to make it 11. That's a little bit evil. But I like putting that on here. You got to make sure you actually answer the question. The total number of minutes they can talk is 11. Okay. All right. Now, what do you guys think? Look at number 5 now. Let me see what you guys can do. I kind of had a little bit of fun because you heard about the College of the Sequoias and the College of the Canyons, I think, and the whatever. So, College of the Bananas. Say again? So there is 10 minutes of additional time because I still have to pay for that first minute. So there's 11 total minutes that I can talk. $4 for the first minute, and then $1.25 for the additional minutes. That's 11 minutes. Now look at the next one. Just look at the College of the Bananas. Can you write? Now what is it that I don't know in this problem? In fact, let's take a step back. Just read the whole problem. College of the Bananas. Is their enrollment going up or down? It's going up. And they start at 12,000 something, right? And they have an increasing enrollment. Apple College has more students, but they have a decline, don't they? So doesn't it make sense that at some point those two are going to become the same, assuming that they continue on the same trend? Are you guys with me? So one's got to increase, but it starts lower. The other's got to decrease, but it starts higher. And that at some point they are going to be what to each other? Which means they're going to be equal to each other. So that's where the equation's going to come from. If you can write an expression for the first college, and then an expression for the second college, and set them equal to each other, there's your equation. So the thing I don't know is how many years after 2015 this is going to happen, right? Do you guys see that? Yes?
Couldn't you just add up the two numbers and then just build it for the lower number? So you're saying like College of Bananas has a positive, whatever the sum of those.
I see what you're saying. I totally do.
And then you could just get that year.
Make sure that you're going to show me algebra, though.
Okay.
Right? So a few of you guys got your homework back from chapter 3, and you got the answer, and I don't care. Because I think we've had a discussion about the fact that you're in algebra class, so you got to show me algebra. So you can't do that and still show me algebra. Totally. Well, let's look at this one at a time. What about the Bananas College? So they start at 12,450, and what are they doing every year? Adding 950 per year. So doesn't that feel like the one we just did? It's a base amount plus 950 x. Because I don't know how many years I'm going to go for, right? And what about Apple College? Same idea, except they're going down. They start at 23,600, and they're going down by 1,280 per year. And let me stop there. You guys, it's very similar to number 4. It's got that a base amount, plus or minus a change per, in this case, per year. And what we say earlier that we want to do with those two expressions, I want them to be the same. So I want them to be equal to each other. There's a big ass equation there. I want this college's enrollment to equal that college's enrollment. So I had to first make an expression for each college's enrollment, and then I was able to make them equal to each other. That's my equation. It's always, how are the things related? And that's a relatively easy equation to solve, especially now that you can use your calculators and things. Oh, how did I make that so big? Where am I at? You guys with me so far? Is that all right? I think that's right. And then you just have to divide, and that one I'm not going to necessarily. Let's see. Is it just 5? Yeah, it's just 5. Okay, cool. Past Jeff made it come out nice. Thanks, Past Jeff. Let me stop for a minute. Are you guys The hardest part of this whole thing was here. So if you had a problem with this, you should have spoken up there. The rest of it should not be an issue. It's just getting your x's together, getting your numbers together, and then dividing. What's the answer, though? That's not the answer. Yeah, that would be like in the year 5. No. So 5 years after 2015, so supposedly this year, they're good to go. I like that. 2020. Because the X was the number of years after 2015. So both of these, I like to do these in a row because they both had the same base idea. There was a base amount plus something per. And very often that per word is a key for where the variable goes. Guys like that one. Oh, what did X mean? So this is how much it was in 2015 plus so many per year. So X is the number of years past 2015. So 5 years past 2015, 2020. Okay. All right. So, I'm gonna pull out or maybe make up. Let's see what they did to you guys. I think it's section 3.3. No. Where's the geometry? Here we go, 3.4. Want to look at a couple of geometric problems they give you. Let's see, blah, blah, blah. Here's something kind of nifty. So look at 239. It wants you to figure out the last side, right? Go ahead and try to set that up, that equation up using Pythagorean Theorem up there. What's the most important side to identify? What's it called, that side? Across from the right angle. Yeah, hypotenuse. Hypotenuse.
36 or 136.
Hmm?
136 squared.
No. Nope. You got to trust in the algebra. You've done something wrong. Where would 10 go in this equation? In for C. Ah, shit. Try to set the equation up for problem 239. Man, this is really, this whole thing is trying to kill me. All right. Here's somebody's paper that left here. I'm going to call that B just because. So what's the equation look like right at the very beginning?
Where we're trying to find the area?
No. We're just trying to find this side.
I
It's
didn't
not.
hear. Oh, okay.
Yeah. So that's why I'm talking about the Pythagorean Theorem. So I'm going to use this. Oops, get out of there. A squared plus B squared equals C squared. Now, it doesn't matter what you call A and B to be honest. The only one that really matters is C, because the other ones combine to make it. But the way I've set this up, I would make this 6 squared plus, I don't know, squared equals, well, equals 10 squared. All right, let me just stop there. Do you guys see that? Do you understand what I mean? Since it's A squared plus B squared, it doesn't matter what you call A and what you call B, because addition could go, doesn't matter. C is the only one that really matters, and it's the one that's always the biggest, across from the biggest mouth, the largest angle. How do I keep going with this weird thing?
56.
6 times 6,
56.
36, plus B squared equals 100. B squared equals 64, so B equals 8. Good. You just got to think to yourself, what times itself is 64? Now, real quick, now watch. So that means the triangle actually looks like this, 6, 10, and we just figured out this is 8, right? What was the triangle we talked about earlier? 3, 4, 5 was the other triangle we talked about. Do you see how a 6, 8, 10 is just something that is twice as big? Do you guys see that? Isn't that twice as big as a 3, 4, 5 triangle?
Yes.
So watch this. If I had a problem that said this, 33, 44, I know that this one is 55 because it's 11 times as big as a 3, 4, 5. Will that always work? No, it's only if it's one of those special ones. So for example, do they have any that's gross? I think they might only give you nice ones, which would make sense. Yeah, I think they only give you nice. That's good because we're not even talking about square roots yet. So I appreciate that. But if I just did a generic, somebody give me a number. 20. Somebody give me another number.
11.
11. Let me do it this way then. And if I do this, now stay with me, wouldn't this be 11 squared plus 20 squared equals c squared, right?
Yeah.
121 plus 400 equals c squared. C squared equals 521. There is no nice number squared makes 521. So the answer would be the square root of 521. Gross. But that's just what happens normally. There's very few numbers that stay whole numbers when you do this kind of thing. So the problems I gave you should all be whole numbers because we haven't talked about square roots yet. So that would be kind of evil.
We just leave it in square root.
So to be honest, this answer would be this.
That's it.
Yeah. There could be more we could do with it, but we're not even learning that yet. So yeah. Okay. Is that cool? So the Pythagorean problems you have to work with should be just like the 64 one, which you should know it's 8. Okay, I like it. So we got. Ooh, we got lots of time. Let's see. Oh, something I want to show you. We got to do distance, rate, time problems. Yeah, good. So we might as well do that. I'm going to move up to the board, I think, because I don't like it over here. Yeah, okay. Come with me. Does anybody know the equation for distance, rate, and time? Let's figure it out. Let's actually create it. Yeah, there you go. Let's see why that makes sense. So let's say you're traveling 80 miles an hour for 4 hours. How far do you make it? What do you do to figure out how far you make it?
80 times 4.
If you're going 80 miles an hour for 1 hour,
You're going to go 80 miles.
I'm with you, but I don't have everybody. 80 miles an hour for 1 hour, you would go 80 miles. That's by definition. So 80 miles an hour for 2 hours would be 160. So to figure out the distance, it would be 80 times 4. All right, you're not going to play with it. 320 miles, right? So what is the formula then? Well, what's the 80 mile an hour? That's the rate at which we're traveling. So that's R. And 4 hours obviously is the time. So here's the beautiful formula for distance, rate, time. Dirt. D-E-R-T, right? E is equals. Dirt. I like it. So let's look at a problem. Is that cool? That you'll have in here. Yeah, sure, why not? Ooh, I like it. Ooh, this will freak it out. Let's look at Ethan and Leo doing their weird things. Let's really, really look at them close. Get in here. All right. Ethan and Leo start riding their bikes at opposite ends of a 65-mile bike path. So Ethan goes that long, Leo goes that long, they meet on the path. Okay, so here's the path, 65 miles. Ethan starts on one end, Leo starts on the other end, and they meet somewhere in the middle. You guys with me? So what have I done for myself? I've drawn a very, very, very basic sketch of what the hell's going on in the problem. It's going to help me set up the equation in a bit. Now here's definitely somewhere I would use a table to help us out with. I got Ethan and I got Leo. Distance equals rate times time. Let me stop for a minute. And you don't have to use a chart, but it just kind of like helps you figure out where everything goes that's involved in the problem. What do I know for sure about Ethan and Leo? Do I know anything about each of them? For sure, like no question.
They traveled a total of 65 miles.
True, but that's what they did together. I'm talking about each one of them. What do I know for certain? Ethan rode for 1.5 hours, so where does that go? Right there. And then Leo rode for 2 hours. You guys see what I'm saying? That's nice. Those are the things I just know. It's always nice to have some of that. What is the question about? So that's going to tell me what the variable should be. Speed, exactly. What's the speed? So that's going to be my variable. Ethan's speed is 6 miles per hour faster than Leo's. So who's going to be just X for their rate? Leo. And then Ethan's is 6 miles faster, 6 mile an hour faster. So what would go here? Because it's not 6x, right?
X plus 6.
He's not going 6 times as fast. He's going 6 mile an hour faster. That's plus. I like it. Now watch. So if you're going to use a table, here's what you do. You fill in what you know for sure. You fill in what the variables are. And then the last two are filled in by the equation. So distance is rate times time. What would be, now let's start with this one. Distance is rate times time. So what goes here? Distance is rate times time. 2x. You guys see that? Distance is rate times time. 2 times x is 2x. So what goes here? Not so pretty, but still.
1/2 x.
1.5 times x plus 6. It's just rate times time. Now, watch. How does this make sense? If Leo was going 8 miles an hour, how far did he go in 2 hours? 16, which is 2 times 8. So this does represent how far he went total. And so the same way, this represents how far he went total. All right, let me stop for a minute. So all I did here was I have the idea behind everything right there. And I filled in what I knew, I filled in what I didn't know, and then the last empty spot was filled in by this relationship because that relationship is true, period. Now I can say what's supposed to be true about how far Ethan went and how far Leo went. Together they went 65 miles. So what do I do with these? Add them up to make 65. However far this dude went and however far this dude went, together they went 65 miles. So their distance is added 65. This is how most of those distance rate time problems can be attacked. Right? You'll have different parts of this that you know and you don't know, but you can always figure out the empty one just by using the equation. And now this should be that was different. This should be the semi-easy step. If you want to, you can kill your decimal first. Anybody want to do that? Or no? You don't care? It's not going to be that terrible, right? Oh yeah, you're bad. So I get 1.5x. What's 1.5 times 6?
9.
9. 2x. So that's not too bad, right? What's 1.5x plus 2x?
3.5x.
3.5x, and then I can subtract my 9. And then if I divide, do I get anything nice? Doesn't look like it's gonna be nice.
65 minus 9.
What's up?
How did you get some?
Oh, I did something crazy. So when you divide, now it will come out nice. All I gotta do is actually do the math right. It's crazy. So that should come out to be, let me see if I can redeem myself. Am I gonna be able to redeem myself? No.
Nope.
60? Yeah. See? You have little faith. So what's that mean? What's that 16 mean? Go back up to the chart. What does the x represent? The speed of Leo. So this is 60 miles per hour for, is it mile per hour? Yeah. For Leo. And how about for Ethan?
16 plus 6.
Yeah. So Ethan went 22 miles an hour. I like it. Maybe. So here, let me give you one to try on your own. Yeah, let's do that one. Yeah, that'll be fun. It's almost the same. Try this one about Kathy and Cheryl. So this is, by the way, this is section 3.5, if you want to look in your own book, if you have it. Otherwise, it's right here. Doing that one.
Which page is this one?
Say again?
Which page?
It's page 379. It's section 3.5, number 284.
Said 179?
379. Yeah. Chapter section 3.5.